Here we are, guys. We've made it. We're doing stoichiometry. I know it sounds scary and it looks complicated, but I'm going to prove to you that you've been doing stoichiometry in your head for quite some time now. So let's just look at this basic example with cake. So if recipe A, and I know it's a very crude recipe, if recipe A can produce one cake, recipe B, because it has half the amount of the starting ingredients, you should be able to produce just half a cake. In recipe C, if you have twice the starting amount of ingredients or materials, this means you can produce twice the amount of cake. So that means you can make two cakes. So stoichiometry is just an understanding of basic ratios. In chemistry, when you run out of reactants or fuel, the reaction just stops. And the number of products are actually determined from the starting amount of reactants. So likewise, when you're baking anything, whether it's cake or cookies, or you're making food for your family, you have to understand ratios and how many servings your starting amount can produce. That's stoichiometry right there. An airbag will deploy when an electric signal triggers sodium azide, which is NaN3, to decompose and form sodium and nitrogen gas. The nitrogen gas fills up the airbag, keeping you safe from accidents and crashes. Now, designing an effective airbag requires the engineers and the chemists to have knowledge of stoichiometry, because if you have too much starting amount of sodium azide, the airbag gets too large and you end up suffocating during the accident. If the starting amount of sodium azide is not high enough, well then you don't have a big enough airbag and it's ineffective at keeping you safe. So we need the right starting amount of sodium azide so that we produce a perfectly sized airbag that can cushion you in the event of an accident. I'm about to get into stoichiometry, which many students consider to be one of the most difficult topics in chemistry. So it's important that you review my playlist 6 through 10, going as far back as understanding ionic charges, understanding how to name and write formulas for ionic and covalent compounds, balancing equations, and mole concept, because stoichiometry uses all of those skills, and if you're weak in any of those topics, stoichiometry might be difficult for you. I'll just give you an overview of how most stoichiometry problems look. Typically, you're going to be asked to find a balanced equation. That balanced equation is like your recipe for making cake. So when you're making cake, you know what you're starting with. You know how many eggs, how many pounds of sugar and flour you're starting with, and how much cake you can produce from your starting amount of reactant or ingredients. Well, likewise, when you look at your balanced equation, for example, let's say it's hydrogen plus oxygen makes water, well, you know how much starting amount of hydrogen you have. So from there, you can actually solve for how much water can be produced. So I box those in blue. So just pretend hydrogen is like grams of compound A. You're going to work your way towards grams of B, and there's some steps in between, okay? So after you're done balancing the equation, you're going to convert grams of A into moles of A, and then from there you're going to switch from moles of A to moles of B using something I call cut and paste. So that's known as the molar ratio. So it's a way that we switch from reactants to products. And in the last step, you're going to change moles of compound B to grams of B. So looking at the graphic one more time, to get from grams of A to grams of B, you're going to go grams of A to moles of A. You're going to cut and paste to get to moles of B. And then from moles of B, you can get to grams of B. Aluminum sulfate reacts in a double displacement with calcium hydroxide. If you begin with 2.45 grams of aluminum sulfate, how many grams of aluminum hydroxide will be produced? So first start writing down the formulas. Aluminum sulfate is Al2SO43, and I get this from crossing the charges. Calcium hydroxide is CaOH2. Again, cross the charges. And we are going to make calcium sulfate and aluminum hydroxide because this is a double displacement reaction. And I know what their formulas are based off their charges, and we're crisscrossing the charges every time. So I am confident that this skeleton equation is correct. Okay, it looks like I need a 2 in front of the aluminum hydroxide. That will change my hydroxide counts, and then I put a 1, a 3, a 3, and a 2. So that's how I balance this equation. And now I'm going to go ahead and I'm going to box aluminum sulfate, because they tell me I have 2.45 grams of this compound, and I have this as my compound B. So I'm trying to figure out how much of aluminum hydroxide can be produced, which means I will cross out the other 2 distractors in green. Okay, so I don't need those at all for this problem. I'm going to start by writing down what I'm starting with, 2.45 grams of aluminum sulfate, times sign, draw a line. And now in step 2, I'm going to convert grams of reactants to moles of reactants. So that means change my grams of aluminum sulfate to moles of aluminum sulfate. And I'm going to find this as 342 for the molar mass. Okay, so my grams will cancel out. The next step, okay, step 3, use the molar ratio to switch from reactant to product. This is also known as the cut and paste step. So I'm going to write moles of Al2SO43 on the bottom. That's aluminum sulfate. And then on top is the product that I'm solving for. So I'm going to put aluminum hydroxide on top. AlOH3 will go on top. And now I look at their balance equation and I literally just move down the 1 and the 2 in the appropriate spot. Okay, so it's a 2-to-1 ratio. We have 2 aluminum hydroxides for every 1 aluminum sulfate, so that will cancel out. And now I can move on to step 4. Step 4 is convert moles of products to grams of products. So I'm just going to change moles of aluminum hydroxide to grams of aluminum hydroxide. So the molar mass of AlOH3 is 78. Okay, and then in orange you can see how the moles of aluminum hydroxide will cancel out. To get your answer, multiply everything across on the top, 2.45 times 2 times 78, and then divide by the product of all the numbers on the bottom. Divide by 342. Okay, and if you're doing it correctly, you should get 1.12 grams of aluminum hydroxide. So once again, if 2.45 grams of aluminum sulfate is able to produce 1.12 grams of aluminum hydroxide, I want you to think about this. What if I doubled the starting amount of reactant? So now I have 4.9 grams of aluminum sulfate. I should be able to produce twice the amount or double the amount of the products. So it should be 2.24 grams of aluminum hydroxide. So again, that's stoichiometry, and this applies to pretty much anything that's out there, like cooking, baking. If you double the starting amount of your ingredients, you should have twice the amount of food or cake or any type of entree or meal that you're cooking for yourself. Number 2, methanol CH3OH burns in a combustion reaction. If you're given 30.9 grams of methanol, how many grams of steam will be produced? We're going to start by writing a balance equation. So methanol plus oxygen creates CO2 and H2O. Okay, so I know those are the products because this is combustion. Now we're going to try to balance this. Okay, so make sure you rewatch my chapter 10 playlist on combustion, on how to balance these types of reactions here. Okay, so the balance equation is 2 methanol plus 3 oxygens, and this will make 2 carbon dioxides and 4 molecules of water. Now we can try the stoichiometry. So we are given 30.9 grams of methanol. I'm going to go ahead and box methanol. This would be my grams of compound A. And the problem is asking how many grams of water will be produced. So I'm going to box water, and that would be my compound B. I can then cancel out any of the stuff that will not be needed in this problem. So we are going from grams of A to grams of B. 30.9 grams of methanol, time sign, draw a line. Okay, and this first step is just getting grams of methanol into moles of methanol. Okay, so I want my unit to cancel out. 1 mole of methanol has what molar mass? It's got a mass of 32. So the grams of methanol will cancel out. Now we're on step 3. Step 3 is the molar ratio. But to help you out, I just call this the cut and paste step. So we look at the balance equation and you literally just cut and paste the 2 and the 4 in the appropriate spot. So we want 2 moles of methanol to go on the bottom because we want the moles of methanol to cancel out. We want 4 moles of water to go on top because that's the thing that we're solving for. So now using the color green, I will cancel out moles of methanol. That will go away. Okay, we're now on step 4 where it says, if necessary, convert moles of products to grams of products. So we are changing moles of water to grams of water. So 18 grams of water is in 1 mole of water. And using orange, you're going to see how moles of water cancels out. Multiply all the numbers on top. Divide it by 32 times 2, which is 64. And if you're doing it correctly, you should come up with 34.8 grams of water. Okay, so once again, the problem is just saying if you start with 30.9 grams of methanol, you should be able to produce 34.8 grams of water. Number 7, aluminum reacts with silver nitrate in a single displacement reaction. If you begin your experiment with 32.1 grams of aluminum foil, how much silver will be produced? So first, start your balance equation, Al plus AgNO3, and we know that this is single displacement, so Al will combine with aluminum nitrate, and we are going to get silver as the thing that gets displaced. We're going to balance our equation, put a 3 there, put a 3 there, and 1s will go in front. I'm pretty sure this is balanced. Now we can move on. 32.1 grams of aluminum, time sign, draw a line, and we want to change grams of aluminum to moles of aluminum. So 1 mole of Al has a molar mass of 27 grams. So using the color red, I will cancel out grams. Continue on, we're now on step 3. Step 3 is the cut and paste step. So we want to put moles of Al on the bottom so that it eventually cancels. And I'm going to box Al here. And I'm going to box the 3 silvers. Okay, the stuff in the middle we can cancel out because they're not involved in this problem at all. And we want to put moles Ag on top, 3 moles of Ag. And because this is cut and paste, I'm showing you with these little dotted lines exactly where these numbers are coming from. So we want to put 3 over 1 so that the moles of aluminum cancel out, which I'll use in green. Time sign, draw a line, keep going. We want to put moles of Ag, silver, on the bottom, and we want to put grams of silver on top. And the molar mass of silver, if you look off your periodic table, you're going to see that it's 108 grams. Okay, so now our moles of silver will cancel out, so that will cancel out in orange. And this is equal to 385 grams of silver. Okay, and we get that number by multiplying 32.1 times 3 times 108, and then we divide all of that by 27. Number 10, hydrogen gas and oxygen gas are combined in a synthesis reaction. If you begin with 9 grams of hydrogen, how many grams of water do you create? So this is synthesis, it's H2 plus O2, remember those are diatomics, and we're going to make water as a product. We're going to balance with a 2-1-2. And now we're going to figure out, okay, which one's A and which one's B. So A will be hydrogen, that is my compound A, and my compound B is water. So we're going from A to B in this problem. It's just like in that graphic that's right above me. So call hydrogen A, call water compound B. So we've mapped out a plan. We can start by writing down 9 grams of H2, time sign, draw a line. We want grams on the bottom, and we want moles of hydrogen on top. 1 mole of hydrogen weighs 2 grams, so the grams will cancel. Continue onwards to step 3, where it says use the molar ratio. Remember, this is the cut and paste step, so we want moles of H2O on top this time around. Okay, and when you cut and paste, it's just a 2-to-2 ratio, because that's what it says in the balanced equation. You're literally just using the coefficients that you see in the balanced equation for that step. And the last step, time sign, draw a line. Put moles of water on the bottom, and you want to put grams of water on top. So that will allow your moles of water to cancel out. Multiply all the numbers on top. Divide that by the numbers on the bottom, and you're going to get 80.2 grams of water for this one. So we've effectively changed from grams of compound A to grams of B. Number 11, sodium bicarbonate. This is also baking soda. Reacts with hydrochloric acid to produce 3 products: salt, water, and carbon dioxide. We want to figure out how many grams of salt will be made from baking soda in this problem. So first we need a balance equation like always. NaHCO3, that's baking soda's formula, plus HCl, that's hydrochloric, yields salt, NaCl, water, H2O, and carbon dioxide, CO2. And by the way, it's balanced already, so everything is actually just a coefficient of 1. I'm going to go ahead and box sodium bicarbonate. This is baking soda, and we're going to call this compound A. And salt, I'm going to box, and we're going to call this compound B, which means hydrochloric, water, and CO2 you can cross out. We won't be needing them in this problem. So we are going from grams of compound A, which is our sodium bicarbonate, our baking soda. Time sign, draw a line. We want to get grams into moles. So we want to put grams of sodium bicarbonate on the bottom, and you want to put 1 mole of NaHCO3 on top. The molar mass of sodium bicarbonate, okay, so you need to add up sodium, hydrogen, carbon, and the 3 oxygens, and that will give you a mass of 84. Those will cancel out. So now we're in step 3, and step 3 is the molar ratio, the cut and paste step. So moles of NaHCO3 will go on the bottom. Mole of NaCl, salt, will go on the top. That's the thing that you're solving for, so it has to go on top. And because this is a 1-to-1 ratio in the balance equation, you're going to cut and paste a 1/1. So in green, I will make moles of sodium bicarbonate go away. They cross cancel. That's fine. Continue onwards. You want to put 1 mole of salt on the bottom and 58 grams of NaCl on top. That's the molar mass of salt. Cross those out. I'm going to use orange. And now we're left with 0.172 grams of NaCl. So that means 0.25 grams of sodium bicarbonate, baking soda, is able to produce 0.172 grams of salt. And again, stoichiometry is just ratios. So if I had twice the amount of baking soda, the reaction would go on for longer, assuming I have enough hydrochloric acid, and it would also produce twice as much salt. So 0.344 grams of salt. So to summarize stoichiometry, all that you're doing is you're figuring out how many grams of product can be made from your starting amount of ingredients or materials. So you always want to use the graphics that I've provided. I listed all the steps right there. There's basically just 4 steps in stoichiometry. You need a balanced equation because eventually you come upon the cut and paste step where you need the mole-to-mole ratio to switch from reactant to product. So you're always going from grams of compound A to moles of A You're going to cut and paste to get to moles of B. And finally, you end up with grams of B by doing another conversion. So that's stoichiometry right there. It's kind of like baking cake. So you know how many starting ingredients you have. You should have an idea of how many cakes you can produce from that starting amount. Thanks for tuning in, and I'll see you next time on Win Chemistry.